Good morning. It's May 14th, and this is your daily brief in science. Here's everything you need to know. A recent trial published in Nature Communications has unveiled a significant breakthrough in the treatment of aggressive breast cancers linked to BRCA1 and BRCA2 mutations. The study reports a remarkable 100% survival rate for patients who underwent a treatment regimen combining chemotherapy with the targeted drug olaparib after 3 years. This trial was conducted by Addenbrooke's Hospital and the University of Cambridge, involving participants from 23 NHS sites across the UK, showcasing a collaborative effort in cancer research. The innovative concept for the trial emerged from discussions between Professor Abraham and Mark O'Connor from AstraZeneca, highlighting the critical role of partnerships in advancing cancer treatment. Among the 39 patients who received the combined treatment, only one experienced a relapse after 3 years. In stark contrast, 6 out of 45 women in the control group who received only chemotherapy prior to surgery died during the same period. The trial's approach involved administering olaparib for 12 weeks before surgery, deviating from the standard 12-month post-surgery regimen. This shift suggests potential cost-effectiveness for the NHS. The implications of this research may extend beyond breast cancer, potentially benefiting other cancers associated with BRCA mutations, such as ovarian, prostate, and pancreatic cancers. Cancer Research, UK's chief executive, Michelle Mitchell, emphasized the potential for this research to lead to safer and more effective treatments, while also calling for further studies to validate these findings. Future plans include larger studies to confirm the safety and efficacy of this treatment protocol, which may also offer cost-saving benefits to the NHS. A multinational trial involving about 600 patients is planned for next year, which could significantly influence clinical practices if the results are confirmed. Notably, the early administration of olaparib significantly reduced the likelihood of cancer recurrence, underscoring the importance of treatment timing. Olaparib, recognized as the first targeted drug for BRCA-related cancers, works by blocking a protein that repairs DNA in cancer cells, leading to their death. A team of scientists from Binghamton University has shed light on the intriguing phenomenon of water-wrinkled fingertips, sparked by a question from a curious child. Led by biomedical engineer Guy German and recent graduate Rachel Layton, their study aimed to determine if the wrinkling process is consistent after multiple immersions in water. Published in the Journal of the Mechanical Behavior of Biomedical Materials, the research confirms that finger wrinkles do form in a predictable pattern after prolonged exposure to water. The study reveals that these wrinkles result from the contraction of blood vessels beneath the skin, rather than just the swelling of the skin due to water absorption. German explained that prolonged water exposure opens sweat ducts, allowing water to penetrate skin tissue and reduce salt levels, which leads to blood vessel constriction. This wrinkling occurs specifically in glabrous skin, which is rich in sensory receptors and lacks hair, ultimately enhancing grip on slippery surfaces. Interestingly, the research found that individuals with median nerve damage do not develop finger wrinkles, indicating a connection between nerve function and this physiological response. The implications of this study extend into forensic science, particularly in fingerprinting and identifying bodies recovered from water. German expressed enthusiasm for further exploration into how skin immersion affects physiological responses, highlighting the potential for new scientific discoveries in this area. Images taken after each immersion showed similar raised loops and ridges, confirming the static nature of blood vessel positioning during the wrinkling process. His personal interest in this research is influenced by his father's experience as a police officer, making the findings particularly significant. A recent study from the Peikhauer Institute for Learning and Memory at MIT has revealed intriguing insights into how ketamine and dexmedetomidine, despite their different molecular actions, produce similar anesthetic effects by altering brainwave phases. The research highlights a significant misalignment in brainwave phases across various regions of the prefrontal cortex, indicating notable changes associated with unconsciousness. When brainwaves are synchronized, cognitive functions such as attention and perception remain intact. However, when these waves fall out of sync, unconsciousness occurs. The study demonstrated that both anesthetics enhance phase locking at low frequencies, particularly between the brain hemispheres, while simultaneously decreasing local cortical communication. Researchers observed substantial changes in phase locking during anesthesia, with interhemispheric alignment increasing and local coherence decreasing. This groundbreaking research enhances our understanding of the dynamics between consciousness and unconsciousness. The findings suggest that monitoring phase shifts in brain waves could enable anesthesiologists to optimize drug dosing in real time, irrespective of the anesthetic administered. Collaboration with anesthesiologist Emory N. Brown has shown that EEG monitoring can safely reduce anesthetic doses, as evidenced by a clinical trial in Japan. In this trial, monitoring brainwave activity allowed for lower doses of sevoflurane in pediatric surgeries, resulting in safer outcomes and reduced postoperative delirium. The research was supported by multiple institutions, including the U.S. Department of Energy and the National Institutes of Health, and the findings have been published in the journal Cell Reports. The study's authors include notable researchers such as Alexandra G. Barden, Emory N. Brown, and Earl K. Miller. Further research is planned to explore the effects of other anesthetics, like propofol, on phase alignment, as well as to differentiate between anesthesia and sleep states based on brainwave patterns. Researchers at EMPA have made a breakthrough in sustainable materials by developing a biodegradable, tear-resistant, and edible substance derived from the mycelium of the split-gill mushroom. This innovative material circumvents the trade-offs often seen with traditional natural materials, offering a promising alternative. To optimize the material's properties, the researchers enhanced a specific strain of the split-gill mushroom to produce high levels of two essential macromolecules, the polysaccharide known as schizophilin and the protein hydrophobin. Mycelium, which is the root-like structure of fungi, plays a crucial role in this development. It utilizes its extracellular matrix to provide both structural and functional properties, effectively avoiding the performance sustainability trade-off typical with conventional materials. The study, published in the journal Advanced Materials, showcases the use of mycelium without chemical processing, resulting in a versatile and sustainable bio-based material. Laboratory tests have demonstrated the living mycelium material's versatility, indicating potential applications as a plastic-like film and an emulsion stabilizer due to its natural emulsifying properties. This research highlights the material's adaptability, suggesting it could be utilized in creating compostable bags for organic waste and biodegradable moisture sensors for sustainable electronics. Looking ahead, the researchers plan to explore further applications where the environmental interactions of this material could be advantageous. Future projects may integrate mycelium with other technologies to develop sustainable batteries, including biodegradable options featuring living fungal components. While challenges remain in working with living materials, these interactions could also provide benefits in specific applications. A recent study from the University of Delaware is shining a light on the impact of physical play on cognitive functioning in children with autism. Professor Anjana Bhatt, leading research at the Move to Learn Innovation Lab, focused on how different types of play affect cognitive skills in autistic children aged 5 to 15. The study, funded by the Delaware INBRE Pilot Project Award, divided participants into two groups, one engaged in whole-body movement activities and the other in sedentary play. Children in the movement group participated in gross motor activities, which included decision-making tasks like jumping over obstacles and dancing to music. In contrast, the sedentary group engaged in seated activities such as building blocks. The findings, published in the journal Disability and Rehabilitation, revealed that the movement group showed significant improvements in executive functioning skills crucial for decision-making and task management. The research suggests that exercise enhances blood flow to the prefrontal cortex, a brain area critical for cognitive performance, while no cognitive improvements were noted in the sedentary play group. Previous studies have indicated that improved executive functioning in autistic children correlates with fewer negative behaviors, a trend confirmed by Bhatt's research. Bhatt emphasizes the need for a greater focus on gross motor skills within occupational therapy for children with autism, noting that current therapies largely emphasize fine motor skills and emotional regulation. Graduate student Cameron Lombardi, involved in the research, has begun incorporating movement breaks into her pediatric occupational therapy practice to enhance engagement. Fei Shen, a mother of 2 boys with autism, shared her experience, highlighting the transformative effect of movement on her children's focus and daily tasks. BAT aims to secure federal funding for a larger study that will utilize neuroimaging to further validate the benefits of movement on cognitive performance. She also advocates for increased movement breaks in school settings to improve attention spans and learning abilities, particularly as physical education time decreases in middle school. Conducted from 2020 to 2022, the study showed positive outcomes whether interventions were delivered in person or via telehealth, supporting the effectiveness of remote therapy. This has been your Daily Brief in Science. To read more about these stories, follow the links in the episode bio. You can also subscribe to these updates via email at www.brief.news. For more daily podcasts about the topics you love, visit brief.news/podcasts. Tune in tomorrow. We'll be back with everything you need to know.